Hello and welcome to this video. As you are here for this tutorial, we assume that you are interested in using one of our services available in openEO Algorithm Plaza. Throughout this tutorial, we will guide you on executing a service using the openEO Python client library. However, please note that you can also programmatically execute the service using R or JavaScript. For non-programmers, accessing the services through openEO Web Editor is a recommended option. We have a separate video tutorial that demonstrates an example of accessing these services via the openEO Web Editor. We will begin by identifying the service that suits our use case. Explore your details, access and execute the service using openEO Python client, and download the result. In summary, the goal of this tutorial is similar to that of executing service using Web Editor, with the exception that here we accomplish it programmatically. So let's get started. Under the catalog in the openEO marketplace of this ecosystem, you can visualize and use among several services. Within the context of Earth observation, these services can do anything from computing a simple NDVI for a bounding box to exposing a complex peer-reviewed algorithms. For this example, I want to use MSI, that is Moisture Stress Index. As mentioned before, there is a separate tutorial available for accessing the service through openEO Web Editor. However, in this tutorial, we will focus only on executing the service programmatically. Please note that these are the parameters that you will need to provide when using this service. Additionally, a sample code is provided on how you can use this service with the openEO Python client library. Once you are authenticated, you can proceed by specifying the area of interest and temporal extent for this service. Next, you will need to load the saved process from the openEO backend using the designated name and namespace, considering the specified date and area. It is important to note the output format of the result. Now, let's put the theory into practice and execute the steps together. Though I am using Jupyter Lab Console, you have the flexibility to use any Python programming environment of your choice. Let's begin by authenticating the account. If this is your first time using this environment for authenticating with openEO API, the output of the authentication command may vary. To learn more about how to authenticate your account, we recommend watching our openEO authentication video tutorial. Next, we need to define area of interest and temporal extent. In this case, we have directly defined our area, but it is also possible to load it as a save file or GeoJSON file. However, ensure that you read the file in a way that the final input to the process is in the form of feature collection. Next, you need to define the public URL provided by the service provider. This is crucial for establishing the connection and accessing the service. Finally, we load the process and provide all the necessary parameters. This step ensures the service is properly configured and ready to be executed. Though in this example we are using synchronous based method, if needed you can also use the batch job based method. For more detailed information on batch job based method, we encourage you to refer to our batch job tutorial or explore the openEO documentation. As you can see, the process was completed and this was our final result. If you have any queries or questions along the way, we kindly request you to submit them as a ticket in the Copernicus Data Space Ecosystem Help Center. Our dedicated support team will be happy to help you. Thank you for listening.